Section 3.2 is solving equations with like terms in parentheses. I can solve equations using the distributive property. In example 1, it says writing and solving an equation. We want to find how many pom-poms and noisemaker the cheerleaders can afford to buy if they buy equal numbers of pom-poms and noisemakers, given that they want to buy a banner that costs $47, pom-poms that cost $5.20 each, noisemakers that cost 80 cents each, and they have a total budget of $377 for the game. And this is all based off the school spirit problem on page 125. So, the amount of money that they have to spend, their total budget, is $377. So now, all the things that they spend money on is going to equal that. The things that they want to buy. They want to buy a banner. A banner, one banner. $47. They want to buy pom-poms and noisemakers, but they want to buy equal numbers of them. So I'm just going to say that's X. The number of pom-poms is X. The number of noisemakers is X because it's the same. So pom-poms cost $5.20 each. That each means we're going to multiply that times our X. And noisemakers cost 80 cents each. So I multiply that because it's each times that X. Okay, and it's X is our number of pom-poms and noisemakers because they want equal amounts. So I don't need a different variable for pom-poms and noisemakers. They can be the same since they want the same amount. Now, when we try and solve an equation, we always want both expressions to be simplified. If I look here, my left side is not as simple as I can get it. I can simplify this expression by combining like terms. Here I get 6 times X. 520 plus 80 gives me $6 times that number of pom-poms. I did not change the fact that it's 47, and it's a positive 6, so plus 6, and it is still equal to that 377. Now, I'm going to try and get my variable alone. Once we get to this step, it's just like we did in section 3.1. We get rid of any adding or subtracting first. Right now I have a positive 47, so I subtract 47. I get rid of anything that's not with my variable first. Okay, we're only getting one banner. We subtract how much the banner costs, and that gives us a total amount left. So 6x is going to equal $330. So we have $330 left to spend on noisemakers and pom-poms. My x is being multiplied, so I get rid of it by dividing. And here I'm going to get 55. So we can buy 55 pom-poms and 55 noisemakers, spend our total budget, and give those out at the pep rally. We can use the distributive property to solve equations involving parentheses. So again, when we go to solve equations, we always want to have both expressions completely simplified. If I look here, my left side is as simple as I can get it, negative 21. My right side, however, is not. I can simplify that by distributing. Again, in order for it to be completely simplified, we have no like terms, no parentheses. So since I'm multiplying with that 7, I'm going to keep multiplying. I'm going to take 7 times each term in my parentheses. I have a 3 and I have a negative x. We take the sign with the number. I have not changed that left side. So again, it's still a negative 21. I can simplify my right side by actually multiplying here. 21 minus 7x. There's a 1 in front of this x if we don't see a number. 7 times negative 1 is negative 7. Now, it's a two-step equation just like it was in section 3.1. The first thing I'm going to do is get rid of my 21. Again, we get rid of any adding or subtracting first. We want to just keep our variable term. So right now I have a positive 21. I get rid of it by subtracting. Negative 21 and a negative 21. We add them up, get 42, give that common sign. Positive 21 minus 21 is 0. So all I have left here is that negative 7x. And I did not change that from line to line. Now, my x is being multiplied by negative 7. So I get rid of it by dividing by -7. And it's being multiplied, we get rid of it by dividing. And I get 6 equals x. We can plug that in to check into my original equation. -21 equals 7 times 3 minus x. And we said our x value is 6. We simplify our parentheses first, get -3. And we're multiplying here. -3 times 7 is -21 equals -21. It checks and we are right. So, same thing on B here. In order to solve an equation, we want both sides to be as simple as we can get them. Right now, that's not the case. So I need to get rid of that parentheses by distributing. I start off with multiplication. So I keep that multiplication. I take -3 times each of the pieces. I take a -3 times the 8, and I take a -3 times the -4x. And I haven't changed the fact that it equals 12. I haven't done anything to give it any reason for it to be different. All I did is took that -3 and distribute it. So I get -24. -3 times a -4 gives me a positive 12. And again, I still have not touched that right side. It's still just a 12. Now if I look, my left side is as simple as I can get it. There's nothing else I can do to simplify that expression. So we start solving. I want to keep my variable term together until the end. Two-step equations, we always add or subtract first. To get rid of a -24, I add 24. And that gets me to 0. So I still have that 12x equals, and again, -24 plus 24 is just 0. Here, 36 on the right side. And again, because I added 24 on the left, I have to add it on the right to keep it equivalent. My x is being multiplied by 12. We get rid of multiplication by dividing. And I do it on both sides to keep it equivalent. I get x equals 3. We can plug that back in to check. -4 times 3 is 12. -12, sorry. 8 minus 12, -4. -4 times -3 is 12. So we are correct there. If we look here, my left expression is not as simple as we can get it. In order to get it simplified, we need to first get rid of those parentheses. And in order to get rid of that multiplication by my difference in the parentheses, I need to distribute. And don't forget that we take the sign with that number. So it's a -2 that I take into both pieces. So -2 times the x, and -2 times that second piece, that -1. Take the sign with the number. Now, I didn't change anything else here. I didn't change that we equal 8, and I also didn't change that 5x at the beginning. I'm going to go ahead and simplify my multiplication here. -2x, -2 times -1 gives me a +2, positive 2 there. And again, I haven't changed my 5x or the fact that it equals 8. Now, if we look, my left side is still not as simple as I can get it. I got rid of my parentheses, so that's the first thing. But now I have two x terms. I have like terms. So I'm going to combine those. I keep my variable, and I do 5 minus 2 to get 3. I didn't change my 2 here. And again, I still have not changed that right side. Finally, we have our left side as simple as we can get it, and now we can solve. I get rid of anything that doesn't have an x first. I get rid of any constants by adding or subtracting. Right now I have a +2, so I subtract 2. And as long as I do it to both sides, we are equivalent. I did not change that 3x. +2 minus 2 gives me 0. And 8 minus 2 gives me 6. My x is being multiplied by 3. I get rid of multiplication by dividing. And here I get x equals 2. To plug it in and check here, we have to plug it into every spot that there's an x. So I plug it into x. and in for x. Here, 2 minus 1 is 1. PEMDAS first. It says we do the parentheses first. So 5 times 2 minus 2 times 1 equals 8. Now we do multiplication, 10 and negative 2. And now we do subtraction, 8 equals 8. We are correct. Feel free to pause here and give this a try. On the left side, my expression is not as simple as I can get it. I don't have any parentheses to get rid of, but I do have like terms. So 3n plus 2n is 5n. I still have that minus 40, and it's still equal to 15. I didn't change any of those pieces. Now, to get my variable by itself, I add to get rid of my subtraction. And if I change one side, I have to change both. I didn't change that 5n or the fact that it's equal since I did it on both sides. 55. My variable is being multiplied by 5, so I get rid of it by dividing by 5. And as long as I do it on both sides, I am good. So here I get 11. If I plug it in to my original equation, we are correct. Give 2 a try if you'd like. I'm going to distribute the 2 to both pieces to get rid of that parentheses. Again, my left side wasn't as simple as I can get it, and that's what we're trying to do. So I take 2 times each of those. No matter what's inside my parentheses, I can take that negative 2 times both pieces. And I didn't change that it equals 6 here. Now I can simplify that. 2 times s is 2s. And 2 times negative 1 is negative 2. Now, it's a two-step equation just like in section 3.1. I get rid of anything that's not attached to my variable, any adding or subtracting first. So I get rid of subtracting 2 by adding 2, and whatever I do to one side, I have to do to both to keep it equivalent. I did not change my 2s. Negative 2 plus 2 is just 0. 6 plus 2 is 8. Now my s is being multiplied by 2. I get rid of that by dividing. And here, I get s equals 4. 4 minus 1 is 3. 3 times 2 is 6. We are correct. On 13, feel free to pause here and give it a try. My left expression is as simple as I can get it, but my right one is not. I have parentheses. I want to try and get rid of those, so I'm going to distribute. And don't forget that we take that sign with the number. So I take the negative 3 into both pieces. I take negative 3. Since I started with multiplication, I keep multiplication. So I multiply it times both things. It does not matter what those things are. Here it's a y and a 4. I didn't change my 13 equals, or my 2y. Now I'm going to simplify. Negative 3y minus 12. And again, I didn't change any of those pieces in black. Now, I'm still not as simple as I can get it on my right side. I have like terms. So 2 minus 3 gives me negative 1 times y. I didn't change my my negative 12 or my 13. Now, y is being multiplied by negative 1 and subtracted by 12. We get rid of our subtraction first by adding. Whatever I do to one side, I do to both. 25 equals that negative 1y. Y is being multiplied. We get rid of multiplication by dividing. So here I get negative 25. Negative 25 equals y. And if we plug it into both spots, we are correct. And that's all I have for section 3.2.